Hello everyone, this is Shankar and welcome to chapter 7 of the microservices with Spring Boot tutorial. So in this chapter, I'm going to talk about Hystrix circuit breaker, and we're going to see how we can make our microservices APIs fault tolerant and how we can prevent a single point of failure inside the microservices ecosystem. So in this tutorial, I'm going to connect or I'm going to call one API from another API, and I'm going to use the discovery server. I'm going to use configuration server, and I'm going to use a Fin client to call one API from another API. And if you're not already familiar with these components, I would recommend you to pause this video and take a look at the previous chapters in this series. So in this demo, we'll be using this project Eureka Discovery Server as our discovery server or as our registry server, and we have already seen this project, or we have already seen this application in our previous chapters, and we'll revisit this application and take a look at the dependencies first inside of the form. So inside the dependencies section, we have a Spring Boot actuator, we have a Spring Cloud Starter Netflix Eureka server. So this dependency is going to make this application act as a discovery server or act as a registry server. And we have DevTools and Spring Boot Starter Test. And let's take a look at the classes, Java classes inside this project. So there's just one class inside this project, and we have the main method inside this class, and we have this enable Eureka server annotation on top of this class. So this would make this application act as a discovery server for our application, for our microservices ecosystem. Right now, let's take a look at the configuration server. So we have already seen this project, or we have already seen this application in our previous chapter where we talk about the configuration server, and we're going to revisit this application. So let's go to the dependencies tab and look at the dependencies for this project. So we have Spring Boot actuator, we have Spring Cloud config server. So this would make this application or this project act as a config server for distributed configuration inside a microservices ecosystem. And we have a Netflix Eureka client. So this project would register itself with the discovery server as a client to the discovery server. And we have DevTools and Spring Boot Starter Test. Right, and let's take a look at the classes for this project. So again, we have only one class inside this project, and we have this enable config server. So this annotation would make this application a configuration server, and we have enable Eureka client. So this application would register itself with the discovery server, which is essentially a Eureka server, right? And inside the application.properties for this project, we have the application name as config server, and this application is supposed to be running on port 8888, and this is the GitHub URL or the GitHub repository where our distributed configuration or our configuration files would be stored. Right, so let's take a look at the configuration store. Let's go to this URL and take a look at the configuration store. So this is a repository which is going to hold our application property files. So these are the properties that we have, and for this location service we have two profiles, dev and QA, and these are the respective property files. So let's go back to the workspace, and we'll be calling a location service. So this location service API, REST API, would be called from within product service API. So let's first take a look at product service, and let's go inside the form and take a look at the dependencies for this project. So we have Spring Boot Starter Web. So this application is a web application, and we have Spring Cloud Starter Netflix Eureka client. So this application would register itself as a client to the discovery server. We have Spring Boot DevTools, we have Spring Boot Starter Test, Spring Cloud Starter OpenFean. So this application would use OpenFean or Fean client to call another service, which is essentially the location service API that we have inside the microservices ecosystem. And we also have Spring Cloud Starter Netflix Hystrix. So this is going to enable the circuit breaking property or the circuit breaking mechanism of this application when it tries to call another API, which is essentially the location service API, right? Now let's take a look at the Java classes for this project. So we have quite a few Java classes for this project, and this is the entry point for this application, and this has the main method. It also has enable Fean clients. So this is going to enable the Fean client property for this application, and that would enable this API to call internally another API and get the result for that API. And let's take a look at the controller. So we have the location service proxy. So this would essentially call the location service API and fetch the result for this endpoint /API/v1/location. So if you're not already familiar with Fean clients and how we can use Fean clients to call one API from another API, I would recommend you to take a look at my video where I talk about how we can use Fean clients to call one API from another API. And inside a product controller, we'll be using the location service proxy to make a call to the location service API, and we'll be clubbing the location service location details into the product details, and we'll be sending out the response to the client, right? And here we have inside this controller class, we have this enable Hystrix. So this is going to enable the circuit breaking property for this application, and this is going to enable Hystrix for this application. And on top of this method get product, so this essentially has the get mapping on top of this, and this is going to expose an endpoint that can be consumed by the clients as an API, as a REST API. And we also have this Hystrix command on top of this method. So inside this we have the fallback method name defined, so that is default product, and we have another method called default product mentioned here. And inside the command properties, we have Hystrix property as name as execution.isolation.thread.timeout in milliseconds. So what, and the value as 2000. So what we are saying is, if we are not able to fetch this location service, or we are not able to execute this method within 2000 milliseconds, we should be returning a fallback. We should be returning to this, or we should be calling this method and returning the result from this method instead of returning the result from this method. So we'll be doing this when the location service might not be working, or when the location service might not be up and running. So we'll not be waiting for it forever, and if this is not up and running, we'll not be having a single point of failure in our application. We'd rather be going back, or we'd rather be falling back to the fallback method that we have defined here, and that is default product, and it would be sending out a default result instead of bringing down the whole system, right? And apart from that, we also have the application.properties file inside this project. So this has the name of the application as product service, and it would be running on 8182, right? And this is the location service that would be called from inside the product service API. And let's first take a look at the POM for this API, or for this application. So we have a Spring Boot Starter Web. So this is a web application. We have Netflix Eureka client. So this application would register itself as a client to the discovery server. And we have Spring Boot Starter Test, Spring Cloud Starter Config. So this application is going to connect to the configuration server for distributed configuration, and to read the configuration properties or configurations from a distributed source or from a separate repository, which is essentially a Git repository that we are using to store our configuration details. And then we have Spring Cloud, a Spring Starter Actuator, and we have DevTools, right? So let's take a look at the Java classes for this project. So first up, we have this location service application.java class, and this has a main method, and there's a plain and simple entry point for a Spring application or Spring Boot application. And let's go to the controller. So here we can see we are reading the properties from some external file, from some external properties file. And if you're not already familiar with how we can distribute our configurations or how we can distribute our properties inside our microservices application, I would recommend you to check out my video or check out the chapter where I talk about distributed configuration in microservices ecosystem. And inside this class, we have this get location. Method. So this has the get mapping on top of it, and this is essentially an endpoint that can be called by a client, and this is just returning a new location object, right? And let's take a look at the location model. So this is a very plain and simple Pojo class, a Java Pojo class, and it has got 4 attributes: city, zip code, street, and port, right? That's all for the Java classes. Now let's take a look at the application.properties file. So this just has the name of the application as location service application, right? So now let's take a look at the Eureka server dashboard that we have. We already have the services up and running. So I just go to the web browser and take a look at the Eureka server dashboard. So let's refresh this. So this is what we have on our Eureka server dashboard. We have the config server registered with the Eureka server, and it is running on port 8888. We have the Eureka server itself registered with the Eureka server. We have the location service and we have the product service. So what we're going to do is we're going to use the product service. We're going to call the product service, and the product service is going to internally call the location service, and the location service is going to read the properties, or is going to read the configuration from the configuration server, which is essentially this GitHub repository that we have used to store the location details or the properties for the location API. And let's go to Postman and use the product service endpoint or URL to call the product service API. Alright, so this is how our endpoint URL is going to look like. So we have /API/v1/product. Let's take a look at the controller class inside the product service application. So we have this request mapping /API/v1, and inside the get mapping we have this /product. So our complete URL is going to look like this: /API/v1/product, right? Now let's click on send. So we can see we have our product details here. We have the product name, we have the product ID, and we have the location details that is being read from another API. And these attributes, city, zip code, and street, are being read from this property file, which we have inside our Git repository. So we have the city as Bangalore, the zip as 1111, and street as Baker Street, right? Now let's do something. Let's go to our product. Let's go to our location service controller class, and let's just make the thread sleep for 4000 milliseconds. And inside the product controller, what we are saying is this thread or this service or this method should run within 2000 milliseconds, and if it doesn't run within 2000 milliseconds, it's going to time out and it's going to fall back to this method, and we're going to send this location as unavailable. We're going to set the city and we're going to set the street as unavailable for the location, for the location, and we're going to set that to the product and send the response, right? Now let's go back to our Eureka server console or Eureka server dashboard and see if our location service is up and running or not. So it is still not registered with the Eureka server. So let's refresh again. Okay, so now we have the location service registered with the Eureka server. Now let's go back to Postman and try to send this again. So this time we can see we have the product name and the product ID, but inside the location section we don't have the city and the street and the zip code and port. We have the city as unavailable and the street as unavailable. So this is being set by this fallback method inside this fallback method. So because this location service is taking more than 2000 milliseconds to run, because we are making the thread sleep for 4000 milliseconds, so this service is falling back to this method and it is returning the default or the default location for the product, and that is what we see on Postman, right? So that is how we can use Hystrix circuit breaker to prevent having a single point of failure inside a microservices environment or inside a microservices ecosystem. And when we are trying to call an API from another API, we can make sure that if the other API is not responding, or if the internal API is not responding, we do not fail the whole system. Rather, we send a default value for that application, and when the internal API is back up and running, we can use the actual values for that. So that is all for this chapter, and in the next chapter we're going to take a look at how we can set up an API gateway for our APIs to be consumed by the external world. And I hope you guys enjoy this video, and if you did enjoy, please give it a thumbs up, and thanks for watching.